All right. Get my levels here. Microphone. Welcome back. Hello. I am your host, Agent Ultra, and I'm back from vacation. So these streams I usually do, I was doing them on Wednesday nights, moving them to Tuesday nights, doing them at 10 after 8 in the Eastern Standard Time Zone. Welcome. So what I do on this stream, I make stuff in Haskell for your entertainment and amusement and learning and for my learning and just so that I'm like always kind of working on something and have projects to do and stuff to do. So what are we going to do now? Recently it's not quite released yet, but it's just a little things I got to do to get the Tiger Beetle client we've been building up and ready to go. That's almost done. Been working on that quite a bit lately, so that 1.0 release should be really soon. And then, what are we going to do? Well, I might continue to stream myself working on the library as I go along, but I thought maybe we should start a new project. Why not? Something new, something fresh, something fun. And I thought, why not try making a mud? So you don't know what a mud is. That's okay. I'm going to teach you. I'm going to tell you all about it right now. Multi-user dungeon. It's a very old school kind of game. Multiplayer game from like way back when. I used to play these all the time. Multi-user dungeons. They're primarily text-based. We've done some text-based-ish type games on the stream before. And the difference between a project like that, what we've done before, and this one, would be that it's multiplayer. So we could do some network programming, some concurrency, right? Things like that. We don't have to worry about fancy graphics too much. Obviously, being a mud. Yeah, hopefully I won't get too carried away with it, but could be pretty straightforward. And yeah, so I don't know. I kind of just came up with this at the last minute. Hopefully this will be fun for all of us learning about stuff. And let's see what we can do, and we can get Haskell to do. So first things first, maybe like a rough sketch of what we're gonna build is gonna look like, roughly, maybe. I'm thinking I'm gonna try to keep this as simple as we can. Or, well, I don't know. Maybe we should make it a good server that somebody would actually want to use instead of like just something that works. I don't know. I haven't really made any decisions on that yet, actually. So let's just talk about MUDs and like general architecture and kind of sketch some things out and see where we want to go here. All right. So obviously it's going to be running as a server, right? So it's going to be hosted on a machine somewhere. It's going to be connected up to a network interface and exposed. So clients from other places across the internet or across the network can connect to it and get data from it. At its core, a MUD is basically like a back and forth, just like the text-based game we made ages ago, where you input some text, a command into the server, and the server updates the state of the world, the virtual world being simulated on the server, and sends back some text about like what happened or what you see, that kind of thing. So it's very like a request response kind of thing, except the server is kind of like ticking away. Like the simulation should run consistently, unlike usually like a single player text-based game where we could just wait for the input and process it. In a multi-user situation, excuse me there. In a multi-user situation, like the world should react, even if you're just standing there. The world should be doing stuff, right? So in our server, we're going to have some kind of networking layer. Has to be this pink box here. The network. Right. I'll make that a little smaller so my next layer isn't so thick. So this is going to handle all the clients connecting to it. Right. It's going to be a two-way connection. Right. There could be more than one client. Right. Presumably, if it's a popular server, it'll have more than one client, more than one person playing the game. Right. All right, so with the networking is just going to establish the connection to the client, and it's going to keep an ID for that client so we know like what updates we have to send to whom, whoever's connected, right? Maybe there'll be like, well, there's probably some kind of authentication type thingy. Right on the other side of this, like we got to have some kind of authorization or authentication or account service. And then the main, that's a kind of tertiary off to the side there. We need that, right? We also need a layer for running the simulation itself. The sim. Okay. And so the simulation is going to take care of like the persistent state of the world, right? What all the objects are, the entities are, what the space is, and running things. And then there should be, like, common in a lot of MUD architectures, a lot of MUD servers, is the idea of like a MUD lib, where you have some user space code and data for defining the game itself. And so the sim reads in that MUD lib, right? And the MUD lib contains code and some kind of scripting language to execute the rules of the simulation, right? So if you want to be able to say that like a sword does 10 damage against monsters or whatever, then you define that in your MUD lib, in your MUD code. And the sim just executes stuff. Right, just runs the simulation. Has some bare bones ideas about the kinds of objects that you can represent in the MUD lib, but for the most part, doesn't care about the business logic. That's all kind of in the MUD lib down here. Alright, so your game, basically your game rules, your entities, what does a player's character look like? What properties does it have? And what monsters are there? What the rooms are in the map? And things like that. Right? Oof. Right, so that's kind of the gist of what we'll try and build. Maybe. A little while, see how far we get. Alright. And so basically the client sends a command to the network layer. The network layer just you know, sets up the connection for the client. You know, says, okay, this client here at this address is connected. They're authenticated or not. Right, it has to call the authentication service. Once the user's authenticated, right, then we say, okay, they're allowed to be on the server. We can set them up in the simulation. Add them to the simulation, and then they can receive updates from the simulation as it proceeds. Yeah. Cool. Okie dokie. So let's get the basics going. Let's get the server up and running and just make a little echo server to start. Something we can connect to. And it just tells us like we're connected and then closes the connection. Something like that. Also, we need an all-important step. We're missing an all-important step. We need a name for this project. This new Modus code project, new mud server we're gonna build. Already, I think. Let's see. Is Lambda mud taken? I know Lambda Moo is. Lambda mud is. Somebody's got a server called Lambda mud already. We could call it... I don't know. Bakamud? Sure. This is a silly name. Okay. Let's pop open ye olde editor. Or programming environment. On Emacs. Okay. And we'll create a project here. Yep. Create a README. First thing, you gotta have a README. I don't know if it's going to be simple. A basic mud. There we go. Now it's official. Okay, let's go and use... version of Cabal do we have? Cabal version 3.8.1. Pretty recent. Not recent-ish. And which GHC am I running right now? 9.4. Not too old, but let's try getting about 9.6. And a more recent Cabal, and then we'll get a project started. By the way, if this is your first time tuning in, watching the stream, welcome. If you have any questions at all, I like distractions and diversions. I'm happy to answer them. So feel free. Alright, installing GHC may take a while. Okay. What can we do in the meantime? Work on our text file, basic mud server. I don't really know much to say about it. Well, let's read up on the library. So what we're going to need to do to get the network library going is we're going to need networking. Sockets. Network.socket. The network library is our low-level networking interface for Haskell. Very, very low level. All right, here's a minimal example of a TCP server. All right. In fact, this is pretty much what we're going to implement. Although, why does it say from network run package? Pretty much. So we'll use the usual library and executable approach. I'll put source here and call Bakamud and network server. Okay, we got 9.6.7, good. Let's get a later cabal. Okay, and set that as and set you there. But okay. Okay, there we go. There we go. 9.6%. Great. I'm gonna go 3. Actually, you know what? Let's Control C out of this. That. We'll let Cabal create it. Library and executable. 3. No. Sounds good. That's good. Sure. Yeah. 3 clause. It's usually what I often use, but yeah, why not? I don't have a URL for it yet. I think one of the fun things with this project is going to be something that I messed around with a couple of years ago is like scripting languages in Haskell. So like I think we might make this the mudlib code. Make this programmable in something like Lua. We'll experiment the Lua bindings for Haskell. Source, yeah. And language for our library. Let's do 2021. So we're at 9.6. Main HS is good. Half is fine. That's good. Test suite, sure. Yeah. Add those. Might rebase that in a sec. Let's go into source. Okay, we're gonna get rid of my lib and all that stuff. Source. Bakamud and great slash network slash server. Hey Twitch D, how's it going? Welcome to the stream. What are we working on today? Well, I'm back from vacation. I'm working on, yeah. We're gonna try making a mud server, a multi-user dungeon, a multiplayer text-based game. And see what we can learn. Experiment with some cool Haskell libraries. And mess around. Yeah. Let's get rid of my log now. Cool. Look at my deck of ball here. And we got Bakamud network server. So we're just going to implement the server layer at the moment, just trying to get a basic server running that we can connect to. It just responds with like hello world and then terminates our connection. Something basic. I don't need the dash there. It's okay, that's because we haven't added it quite yet. Gotta fix the app. And there we go. So we'll import .network server. Just get rid of that. That should be fine to build at least, even though we don't use it. Let's do that. There we go. I think we can add a git ignore for that, but just do this first. We will tweak. Just pick. Okay, we'll add git ignore. Does New style. Sweet. Okay, so first things first. Let's get a server. Let's do a server, shall we? We need the network library. Let's add it. Let's say we need 3.2.8.0. Do I have an existing mod I'm basing my game off of, or any theme? This is kind of off the cuff. I'm basing it off of, like... I guess the closest thing would be either, like, maybe... LP-style mods. Mud code bases, so... I kind of want to experiment with... instead of the code base being, like, something you hack the Haskell code to make your game in, you can have your own mudlib code, like user scripts. So have some kind of user scripting system that lets you kind of define your own game using your mudlib code. And I was thinking we'd probably just use something like Lua for that, because there's like Haskell bindings for Lua already. Metamud. Something like that, yeah. And I'm thinking, like, for that simulation layer I was mentioning at the beginning, I want to try and experiment with, like, maybe an entity component system. Mapping, there's some ideas there we could try experimenting with. That could be pretty interesting. One of the ones I was thinking that might be fun to try and do is more like a tile-based, rather than a room-based mud type thing. So we could have, like, areas you could, like, shoot an arrow and it goes off in a particular direction, that kind of thing. Really, the sky's the limit. Obviously, we could go nuts with this. Or we could just keep it small and simple and just say, like, okay, as long as we can move from room to room, hack a monster, and chat with our friends, that's good enough. So, we'll see. Mainly to learn and satisfy curiosity. So, if we catch something interesting, we'll follow it and see what happens. And then we'll learn stuff about Haskell along the way, I'm sure. Interesting libraries and whatnot. Okay. So we basically want something like this, where we have a loop. This just calls run TPC. This is the main one right here. Get an address, get a bracket, resolve the address from the socket. Open. Right, set. This should look fairly familiar if you ever used this, like your operating system APIs. Although I recall from streams of yore that I think it's probably fixed now, but for a long time this library didn't work well on Windows. There's problems with it. I'm running now in Linux, at least virtually, so probably won't be a problem. So something like this kind of code is what we're going to do. So I'm going to have it in our library, our server library. Pop that in here, but it's not the main. So mains are our app. Yeah, we'll pop that over there. And this is going to need some of those imports from network.socket in order to work. Yeah, and I'll also continue working on Tiger Beetle, the client. That one's nearly done. I just didn't want to like. All that's left to do to cut the release right now is pretty boring, so I just didn't want to do that on stream because it's just like documentation, making sure the docs generate right, and doing a bunch of cleanup work, that kind of stuff. So at some point I'll do more work on that library as well, and we'll probably do it on the stream. Okay, so we just use that S. What did they import? S page up by string. Gonna need that. Okay. And there's our run TCP. Can we build it? No. Cabal is not happy with us. What was it? It's just not the right version. Let's try 3. Oh, because of our base. Okay, yeah. Well, it should be 9.8.2. We're on 9.6. Or maybe we gotta go to a slightly earlier version, 9.2.7. Let's try 3.2.7. That seems to be better. We need byte string as well. And the executable probably needed as well. I'll leave both. That's using posting. Okay. Try and keep it similar. Consistent. fix that. Forever. We need void. Send all. Oh, no. There we go. Okay. Basic TCP server. All right, it's running. Let's telnet to it. We set it to 3000. And it goes back to us. I didn't need to do it. Oh, shoot. Lose all other pains. Okay, so then when we got an echo server. Cool. Not a basic TCP echo server. Okay, so what does this TCP server do? Where'd that come? Okay. Maybe there's a host name. We don't have to define it. We could define nothing. Service name, port. And then a function that takes a socket and does some IO action with it. And then returns an IO action. They both return the A. So whatever that is. All right. Resolves the socket, gets an address bracket here. A good old friend bracket. It comes from control exception. That basically acts like a finalizer, right? So if something in this action throws an IO exception, it'll call close on the network socket. And so it tries to open the address, it calls close, and then loop will be our computation that we run. That'll get the result of this function here. Open. All right. So open does a bunch of stuff. Some basic socket options. Reuse address 1. Close on exec if needed. So close on exception. Just a little defensiveness. Binding the sock to the address. And then we listen for events on it, and we return the socket. Then we have our loop, which calls forever, so just forever in a loop. Shh. Again with a bracket. Does this function. We get a connection and appear. It's an interesting comment here. Port finally alone is unlikely to fail, thus leaking connection. But bracket on error above will be necessary if some non-atomic setups, example spawning a subprocess to handle connection, before a proper cleanup of connection is your case. Could be, but it's good to know. We will probably... We'll probably have, let's see, how do we want to structure the threads, basically? One thread per socket, I think. Probably makes sense, right? You could have multiple threads per socket, but you have to make sure that there's only one reader. And one thread just only reads and one thread only writes. I don't know if we need to bother with that though. So, fork finally. Gracefully close connection. Alright, so we can have... Let's open a couple here. Caval, run, Bakamud. And we're going to be telling that client here. $3,000. And we have one here. Two connections, two clients. Alright, it just echoes back to each socket separately. I don't actually know how to kill talent from here. Alright, it's just gonna do internet. It's almost like Vim. No. There we go. It is a bit like Vim. Anyhoozle. Yeah, so there's our basic doohickey. Oh, what the heck? Sorry, stream. I don't know what the hell's going on here. All right. Oh, I see. Okay. There's an overlay I have running to do my fun pen stuff, and it has a hotkey that conflicts with my terminal, which is great. Okay, anyway, let's get back to it. Okay, so what do we want to do now? Now that we've got a connection, let's work on... We can work on the authentication. Or we could just assume you're allowed to be on the server since we're developing locally. And do that part. Or we could just fudge it. Do like basic. Maybe we could do like a little hello message. Well, the other thing we're doing actually kind of wrong with this though actually is with app and main. The talk function here is what's doing all this stuff. Right, so talk we should probably pull over into it's the server. Because that's where the code's gonna go. Projects. Okay, let's clean up some of these errors or warnings. Don't need those anymore. Don't need that anymore. Don't need that anymore. Cool. That's a little better. Okay, talk. So talk is going to wait to get some bytes from the client before it does anything. All right. Probably so I'll give it a type. Move talk to server. So if I just do this, I can go send all to S. I can write some byte string here. I got lots of overloaded strings on. And I can say, welcome to Bakamud. Well, run Bakamud. We telnet in. Welcome to Bakamud. That's a great little welcome message. Hello. Cool. Next, what do we want to do? Display welcome message. Well, we want to be able to talk to other people. Other people connected to the server. The server also should be able to push things out to us. Not a whole lot to do at this layer at the moment. Okay. Let's do the authentication stuff. We'll kind of fudge it a little bit at first, just to get it working. And then we can implement something more serious and proper, like properly handling passwords and checking your login information, all that sort of stuff. But let's do something simple. And see if we can log in. And then when you're logged in, so when you initially connect, you should be connected to an anonymous thing. So yeah, let's have that. Let's do that. We'll do that. So when you initially connect, we should have a map of all of the, in the server, of all of the connections that are present on the server at the moment. All right, so let's do that. Because ultimately we want the server to be able to, like, have queues of messages to send to different clients for different things. So let's do that. So should that be in the network layer, the network part of things? Or is that more like a server concept, maybe an authentication concept? Well, we're just talking the connections, and we could have the connection have some state associated to it, whether it's authenticated or not. So maybe networking. We'll call connection. All right. Does that work? There we go. Let's call it right, and just leave it like this for now. We have an authentication state. You're either authenticated or you're not. You're anonymous. So then the connection state. I'm going to use this. We're gonna go as type state. Auth state. We'll give it an EQ and show instance. Update that Cabal file. Get that built. Oops. Hey. My bad. There we go. Okay, so now we have a way to represent a connection state. So when we get a connection, like a socket connection, and we resolve that in our server, like in here, we get welcome to Bakamud, right? We should, I think, create a map for that connection and keep that connection information, like the socket, the connection state, whether it's authenticated or not. That's about it so far. So we need a place to store all of that. Basic connection state information. Okay, so we need two things then. We need a state for the server, where this map is, and what connections are currently in it. All right, and then when we connect, we get a connection. We have to create that connection information and add it to the map. Okay, let's do... server state. I gotta fix that snippet. Thank you. We might not be able to have EQ and show on this one, but we're gonna put this map, say here. Connections. And this could be a map, connection ID, connection. Connection ID. make connection IDs. Text. Integers. So we're going to need containers. Probably going to need the constructor as well, so pulling that in. We need map. Yeah, we'll bring in the qualified here. Okay. Probably get a warning as we're not using it yet, but we will in a moment. Okay. So when we run the TPCP server, we need to initialize our state as well. Now we could create a nice little monad for ourselves here. Or I can create a variable here that we could pass around. We won't be able to mutate the state. So we'll have to wrap that in something that would let us pass it around to threads. And we could do that with STM. With TM vars, transactional memory variable. Or the other approach we could take is we can make this a monad we can unwrap to IO and run in IO. And that could hold our state. It could be like a reader or something like that. But that would have IO refs anyway. So let's just try the IO ref approach. Even var or whatever. Or an IO ref. TVAR, sorry. TVAR, something I want. So call it server states. It'll be new t var io. And then we'll have empty server state. We're gonna need to import that. I think that means we're gonna need to update the Cabal file as well. Let's see, STM. Two 5.1. Let's try 2531. That looks good. Okay, so while that's building, let's get our going. We're gonna need to fix it. But it's okay. Let's just do this. Work in progress. Added the connection map. Server state, which has the connection map. We'll pass that in to loop. Not so many parentheses there. There we go. That's gotta go first. Let's add the type in there. I think the type this is going to be wrong. Probably that one too. Let's get GHC to tell me what the type should be. Header info, that's it. Perfect. Okay. Okay, so now we got the server state variable thing in there. And our server function can now get a copy of that T-var, get a reference to that T-var. So in here, when we get a connection, we're going to add it to our map by modifying the T-var. So in here, we have it forever, bracket on error, call accept on socket, and close on fire. So if we call accept, then we get this function here is what we're going to run. Connection appear, void, fork bind leads server and connection. Server is our function up here. That's going to be talk. So we'll pass through the server state here. Cool, so now we have we have to pass that through and on the loop. And send all. Oh, that's not going to match up the types. That's why we needed that. Okay, I'll fix that. I missed one. Yeah, S. Okay. Okay, so when we finally get here, we've got our server state passed through to talk now. Talk is an IO action. Talk can now manipulate the T-var and update the state. So let's get the message. And if it's not null, then we'll just match on it. Message. And if it's something silly like auth, then something. Otherwise, something else. Fix that snippet as well. Let's just use this as the otherwise branch. In either case, we'll pop again. Okay, so if we do get the auth message, though, we're going to do a bunch of stuff here. We're going to create... We need a way to generate a client ID. Create an instance of the client. And add it to our map, our server state. For now, let's just hard code it. Or connection ID, I should say. And our connection it's going to have an auth state of anonymous. And we need to modify the tvar. It takes the tvar and a function. And we have to do that atomically. So modify the server state. And call it add connection. And it will be our connection. And as CID as well. We have to use that. We haven't used those. And server state to server state. Okay, we gotta put something there. We're gonna update this. So now, when we're updating this map, we have the connection ID. Obviously, we have cases here with the map. If the connection ID already exists in the server state map, what do we do? If it doesn't exist, obviously we want to insert it here, assuming that the authentication check worked. And those are our two cases really. So we might have another connection state though. We might have like an idle or a unknown connection state. Although, no, this is just dealing with authentication state, so let's just think about that. So we do basically something here. We're going to insert into the map. Or we could upsert. It's interesting. Interactive altar. Anyways, alter or... Yeah, maybe alter. Okay. We'll go S where... I don't know, this is where I'm going to want lens. I don't know why I did this, but server state connections equals... overloaded record dot. Do I? Oh, what is it? Yeah, it's overloaded record dot. What are you complaining about? Anyway. I'm gonna map.alter some function. Add our key ID. And we'll just connection. Alright, so we just have to put just in there, so we gotta actually pass in. So we've got nothing. Let's just insert it. Otherwise, if we've got something, Let's just leave it the same for now. Oh, it's not in scope. Yeah. Want the constructor for that as well. Okay. So add the connection to the map. Maybe we can have like a little test function. Just call it yo for now. And we'll send all. We might have to do some conversion here. On S. Show. Let's read the server state. That. That's I want some conversion probably because it wants string, but this is a byte. It wants a byte string, but it showed me some string. It's like in code or something like that. Pack cars. Pack. Call it C, and let's C dot connect that. It needs atomically. Cool. All right, let's check it out. Does it work? We'll auth. And we'll yo. Let's just echo it back. Oh, because our pattern match probably isn't exactly right. Maybe there's some hidden characters that come in there. Yeah. we're still getting the duplicate. The echo case. And we're getting our welcome message. Which is not what we want. Every time we loop. We just want that at the startup. I'll fix that later in another one, but let's get this going. Why are we not getting the exact pattern match on the message? It's going to be to get that to actually display. If there's any weird characters in there. Maybe that'll do it. Ah, /r/n. There it is. Perfect. Oh, there we go. And if we go yo, there's our service state. So we see connection ID 1, connection state anonymous. Welcome to Bakamud. Great. Cool. So modify a server. Add connection to connection map. Now, we got to fix that because it's not quite right. It's not the way I want it to be. It's on connection, not on loop. So this talk is the loop. So we actually got to move this code up and out. Let's move the send all state one. Let's try it up here. And put a little do on there. S will be con. Okay, that's better. And then this map stuff. No, that should be fine. We're not doing it. We're only doing it on these special commands. Ultimately, we're going to want to abstract out this logic here and not and special case it, obviously, but be able to handle off commands to various subsystems in the server. So this will handle off, you know, initially when you're connected, you can only do certain things on the server, like authenticate, and maybe some server information, basic stuff, like how to get maybe a server message. But you shouldn't be able to do anything else until you authenticate. And once you're successfully authenticated, then you can do other things. All right, so there's got to be like some kind of system for managing the user input and checking is it allowed kind of thing. It doesn't have to be super complicated. It just has to be like, if they're authenticated, they get access to this. If they're not authenticated, they're restricted to these things. How are we doing for time? 9:49. Not bad. Yeah, cool. That's that. Okay, so dispatching commands and the authentication check, all that sort of stuff. So obviously in a mud sort of situation, we're gonna have to like parse things and parse the user input, turn it into like some kind of command. There's gonna be special server commands, I think, for talking to the authentication service, and like maybe quitting the server or whatever. So like I'd call those like meta commands, and then everything else that the parser parses should go into the logic and be processed by the users, by the logic system, the simulation. All right, so the user scripts for all that stuff and everything else. But we're just about out of time, I think. So we're gonna call it here. I'm gonna find a home for this code just so we can follow along. Unfortunately, it's probably going to be GitHub for now. But I am going to be moving my stuff off of GitHub. And I should probably do that this month, I think. Sooner rather than later. So, just so as you knows. Bakamud. A basic mud. It'll be public. Don't add a readme, no get ignored, no license. Just a plain repo, please. Okay. Let's add that remote. Oh wait, let's clean this up first. This work in progress one was source state connection map. I think I wanted to release up to here. Reword this one, squish that one in. Okay, cool. And remotes. Add. Origin. Okay. So there you go. The code for this project that we just started tonight is there for your pleasure. I'm Agent Ultra. It's been a pleasure. And I say that word a lot, apparently. Pleasure, pleasure, pleasure. Thanks for watching and tuning in. I'm doing these streams now once a week on Tuesday evenings in the Eastern Standard Time Zone at about 10 after 8. I'll have my schedule up on Twitch as soon as possible. You can follow me on the TypeStop server on Mastodon, on the Fediverse there, or on my website at agentultra.com. It's got links to my Twitch and also to my YouTube channel where I back up the VODs for this stream. You can watch past stuff, or if you're in a different time zone, you can watch them there, right? Leave us a like, a subscribe, a comment on YouTube if you're watching there, or if you're on Twitch here, give me a follow. It's greatly appreciated. And well, hopefully we'll see you next week. Take care out there. May all your monads be free and your types always check. Happy hacking. See you soon.